All right, good morning. So let's take a look at the reminders before we dive into some recap and then some new contents. So your lab number 1 has been released. If you got any trouble understanding how to make a progress, please reach out. You got until not the coming Friday, but next Friday to complete lab number 1. I'll release the solution to you right after the deadline. And don't forget your programming test number 1 will count just a few days after lab number 1 is due. So please make sure you really try to struggle through the process and learn. And reach out for help. And from yesterday, the in-lab demo, you can find the recording from the lecture site. I talked a little bit about incremental development for lab 1 or for your programming task. It could be a nice tip for you. Only about 10 minutes. You can check it out, and hopefully that will help. And the mock-up test will be tomorrow, either 5 p.m. or 6 p.m. I'll reach out to you a little bit later today just about some very simple protocol. Since it's a mock-up test, let's make it like a test so you can really get a feel of what a real test will be like. I'll reach out to you. And very important, the guides for your coming written test 1 and programming test 1. Both of them must be taken in person. There are no remote options for these assessments, right? I hope I made it clear when I discuss the syllabus. So if you go to the lecture site, you will see these 2 guides also under here. All right, test guides, right? And there's one section there in the programming test 1. I would like to draw your special attention. All right, so if I open it, for the rest, you can please just make sure to read carefully and then make sure you follow them. That'll be very, very appreciated. And then I want you to look at on page number 4 about the rationales. So for this programming test, we're going to impose some strict policy about compilation penalty, time constraint for short. You're given 80 minutes. And also, you will be graded with some additional grading test cases. If you're wondering about why such policy, I really try to explain the way I'm thinking about why this will be important for your learning. So please read them through. If you want to discuss them, reach out to me. But I just try to explain to you about why the policies are set that way. Okay, if no question about the general administrative issue of the course, let's do a recap about what we said about last time. Okay. Oh, sorry, one more thing, I forgot. For your written test number 1, I think I will try to give you some review session, optional. You can ask me question. I don't really come to campus on Monday usually, so maybe Zoom will be better for me. I haven't decided time yet, but I think now it will be more likely to be a little bit later in the day, maybe after 6 p.m., something like that. Maybe that'll work for some of you. I'll reach out to you, and then I will hold a Zoom session. I'll try to record. I'll definitely record the session because some of you may not be able to make it, so I want to make it fair for everybody. I'll reach out to you, so wait for my email, okay? Okay, let's now have a quick recap, and then we'll move on with the exception stuff. All right, so the first half, last time on Tuesday, we spoke about how you can do automated ID management using the combination of static versus non-static variables in your class, right? Just make sure you understand the pattern. And we also spoke about what if I change the global counter, global counter is static. What if I also change the ID itself to static as well? We talk about the consequence, right? You really want to know how to analyze them. And we talk about other misuse of the static variables. For example, for our programming pattern, what's going to happen if the counter over here is actually static versus non-static, right? We also spoke about it in detail on Tuesday. And this is also a very common error, meaning that you're trying to refer to something that's non-static in a static context. And we also talk about the potential 2 fixes and also criticize on one of them, right? So you really want to go back if you have doubts. And then we started this discussion about caller versus callee. This concept here will be used extensively today when we actually need to explain different concepts in the exception. But today it's going to be a little bit more handy. I will just need to go over some principles first, and then I will develop some example from scratch using my computer. So Hopefully that will just make a little bit more sense. But I can tell you, exception, if you're learning that the first time, is very tricky. So don't feel too frustrated if you're not following 100%. It's normal. What you should do, get some overall idea, which I'll keep repeating, about the overall picture of how things should work. And then what you should do is when you go back, when you prepare for the written test, you may want to go over the slide first, go over the source code, try them out in Eclipse, and also go back to the recording if necessary. That'll be the way to learn. Not one go. You may want to do multiple passes. Okay, we'll talk about caller and callee. Just a very quick reminder. Caller is really the context where you're trying to make a method call. So C1 and 1 will be one example caller. And then we're saying that we're calling this particular method M2. M2 has the context object O, which was declared to be type C2. So that's why we're saying this method being called, which is M2 from C2, that's the callee. Right? We have the caller-callee relationship. You really want to get used to what do I really mean by callee versus caller. And we're going to use them quite a lot today. And this was the last page that we spoke about last time. I do want to add something more to it. But before I do that, do you guys have any questions that you want me to clarify from last time before I pick it up from there? Any points you want me to repeat, clarify?
Just that part of the question.
Oh, that part? You mean can a method be a caller and callee? Okay, sure. So that's an important question here because for a method to be a caller and callee at the same time is actually very common. I would say it happens basically all the time without you even realizing it. So let's say, for example, we know that C1 and 1, beg your pardon. We know that C1 and 1 is already a caller. That one you understand. Good. Now, can C1 and 1 also be a callee? It is possible, but it will be in a different context. So the context we created by making C1 and 1 a callee is to say, let's say in another context, let's say C3 and 3. So C3 and 3 here will be the caller instead. Because it's calling the C1 and 1 over here, so now C1 and 1 is not a callee. Right? So when we talk about the same method being caller and callee at the same time, we're talking about in two different contexts. They are in one context is caller, in the other context is callee. That's what I meant.
But it's not possible to make them caller and callee in the same class?
It is possible. It is possible. So for example, let me emphasize that. It is definitely possible. Let me talk about that one very quickly. So let's say this. If we have, let's say, class, let's say C1, let's say void and 1. Let me put another method here, and 2. Okay, first of all, let's say under C1 and 1, we are trying to make a method call. Let's say we have another class called C2. All right? C2, and then object O will be a new C2 objects. And then here we say O dot, let's say M3. So now in this context over here, you can see C1 and 1 is the caller. As far as this line is concerned. Okay, as far as this method call is concerned, C1 dot and 1 is the caller, whereas C2 dot and 3 is the callee. Are we okay with this? It's N3 actually, because you can see we are calling M3 over here, right? And M3 is actually a method from C2. So that's why I'm saying that's a callee, right? It's a slightly different name from the example we talked about. It's a similar idea. Okay, you were asking about, is it possible for C1 and 1 to be callee in the same class? Yes, it is possible. Let's see. What I can do is I can say I call C1 and 1 in this context over here, which will make C1 and 1 a callee. Let's see. I can say, I can simply make a method call here just to say this dot and 1. This is not so necessary in this case because there's no shadowing, but I'm just putting that just to be very explicit. So if you have that here, so you will see this one's M1, definitely this is referring to C1. So we know that C1 dot M1 is not a Callee, whereas C1 dot M2 is the caller. Right? You can see C1 dot M2 is the caller. Right? Okay. So the main message here is to say now C1 M1 being the caller in this case can also be the Callee at the same time in the same class or in different classes. Okay? I'm glad you asked this question. Actually, this was asked in the afternoon session last time, which I forgot to mention. Okay. All right, any question about caller Callee? All right, if you're still a little bit confused about or to use this very smoothly, we'll see. You will definitely have to struggle through a little bit before it will be more natural to you. It's very natural. All right, let's now move on to this page here. Okay? And we spoke about last time, let's say if you have some entry point or starting point of execution. Let me just make sure I started, okay, I started the right place. Let's say I started execution from here, M1. I'm going to execute some code before I make a method call, in which case this method call has to be executed first before I can continue. All right, let me just write it down. That's something I'd like to say a little bit more, because we also need to understand this kind of so-called suspension idea very well when we talk about exception. Now, I'm going to highlight this particular method call over here. Okay? I'm going to say star over here at the point of the star. M2 is call. Right? There are two things you should know. Number one, the execution of M2 is now prioritized. Meaning that we have to now, rather than continuing, no, we don't do that. We just go to executing the body of the M2. Right? That's why I say it's prioritized. Number two, the remainder of M1. Literally this part over here, the remainder, right? After M2 call, will only be resumed after M2 is finished. Right? Let me just wipe it out. So these are the 2 points you really want to watch out for. And let me say one more thing about a stack. Right? We say there is a stack over here, and then when we first execute M1, we're going to push M1 over here, put it into the stack, right? And then we're going to execute some code here, and as soon as we hit this method call, we're going to put that method call M2 on top. At this point here, M2 is here at the top. That means we have to finish M2, remove it before we can get back to M1, right? That's something we said last time. Let me say it again. M1 here, we put M1 here. And then when we get to M2, we're going to push M2 on top. And we execute M2 for a few lines, and then when we get to N3, we'll put N3 on top. And before we can finish M3, which will be here, we cannot really execute M2 or M1. It got to be one by one. So M3 done first, and then do M2. Once M2 is done, we get back to M1. That's really what we said last time, right? If you are wondering about what should be the detailed tracing of these 3 methods here, you can refer to last time. But do you have any questions about basically using the stack over here to trace the method call? We need that today. All right? Question? Everybody's good? All right. Assuming that you're fine, let's now move on. Let me go back to the slides, and I want to go over a few more principles, and then I can refer back to this diagram. right? Let me just draw one more thing here. If you recall, here, this is the stack. When we first execute, we execute M1, right? And then when we get to this point here, we put M2 on top. And then when we execute M2 over here, and when we reach M3, we put M3 on top again. That's how we build a stack. And let me go over some principle, and I'll come back to this diagram. All right, so the execution of a Java project starts from the main method. That's partially correct. Sometimes it could be the main method or can be a JUnit test. Okay, but main method is good enough for illustration. There's going to be a point where you start the execution, typically the main method. And each line of the method call is going to invoke the implementation, which means if I say I want to invoke this method here, M1, what it's going to do, eventually it's going to execute every line over here, the body of the implementation. If I invoke M2, it's also going to execute the body of implementation for M2, one by one. It's just that whenever you reach any method call in the middle, you have to be more careful because method call means you have to somehow suspend the current execution of M1, for example, in this case, and then go on to execute and finish executing M2 before you can resume. All right? That's the additional detail you have to watch out. And yeah, exactly. So the method may invoke another method. M1 might invoke M2. M2 might invoke M3 in turn. A chain of method call, which we saw last time. And this example here, we're going to talk about it hopefully later today. But for now, I just want to illustrate to you what do we really mean, the top of the stack and also the bottom of the stack. And what do I mean by latest and also the earliest? Right? That's something you also want to observe as well. Something you want to really see from here. Let me just see my notes over here. Okay. I want you to look at this stack over here right now, right? We know how to build this one here. Well, when you see a stack like this, you know the following. Number one, M1 over here, this is the method that was called earliest. We talk about chronological order, like the timing of invoking the method, right? Let me write it down. So the chronological order of method call. Which one goes first? M1, right? We started with M1. From the bottom all the way to the top. M1, and then M2, and then M3. Right? That's something you want to know. Chronological order. And it's going to be M1, followed by N2, followed by N3. Exactly go this way here. Go this way. That's the chronological order. And we can say a little bit more. The bottom of the stack over here, this will be the earliest one. Earliest method call. Symmetrically, the top of the stack will be the latest method that was called, right? The latest method call. Are you okay with the two remarks right now? When you are given a call stack over here, M1, and then M2, and then M3, the bottom there should be the earliest one that's being called. And the top there should be the latest one that's being called, right? And then the order should really go this way. All right? What about the timing of finishing the method call? Which one did we finish first? Did we finish M1 first? Not really, right? Because remember, we have to somehow get rid of this before we can get back to M2. We have to get rid of this before we can get back to M1. M1 will be the last one to be finished, being at the bottom, right? So you want to also contrast this one here. When I say M1 is the earliest method being called, at the same time, it will be the latest one to finish, okay? Okay, symmetrically, When I say M3 is the latest method call, it should be the earliest one that's finished, so I can get to M2. Earliest method finished. And always remember also the chronological order, right? What I just talked about in these two things over here, I just talk about the front and the end, right? The bottom and its top. One more annotation, and usually when you are given a stack, right? Sorry, that's not a stack. Usually when we have a stack, you may get something at the bottom here. This is called the bottom of the stack. Okay, that's the bottom of the stack. And then you may have as many methods as needed for your application, and then this will be the top of the stack, right? So we talk about the bottom and also the top, right? They're different. Okay. Any question here? Okay, and then let's go back there. Yeah, that's exactly the one I just illustrated. And this will be my suggestion. I think let's dive directly into the very details of exceptions today. And then from slide number 5 to number 9, they are really talking about some comparison between console error reporting, like a system that out of print line, some error, versus exception handling. I would suggest you might appreciate this kind of comparison more after you have studied the exceptions for your written test. So I would suggest the following. I'm going to skip, not assign reading, I'm going to skip for now, slide number 5 to slide number 9. They are not included in your written test 1, right? I'll make it clear. I'm going to update the written test 1 guide once I finish the lecture for both sections today. So we're going to skip from number 5 to number 9, okay? We're gonna revisit this part next Tuesday, which will not be covered on your written test 1, so don't worry. What I will do instead is to go to slide number 10. Start from there. Okay? Let me go directly to exception. Okay? What I want to do now is to go over some principle, but the principle here can be a little bit dry. But I'll try my best to visualize it as much as possible. You want to get some idea before we go through some complete example to see how exceptions can be programmed in Java. Okay, let's see this. Okay, let's try. So there is a diagram, which I'm going to show to you very soon. You can also find this diagram here in your lecture site. So that's something you also want to pay attention to. Okay? You can imagine that this is like a call stack over here. Imagine. It's like a call stack. Right? And how many methods do we have in the call stack? 1, 2, 3, and 4. And we talk about the bottom of the stack and the top of the stack. Right? Okay, we'll come back here in just a moment. So what is really an exception? Exception in Java or in any OOP, it's really some events that happen when there is an error. And it's fundamentally different from just system that out the print line into the console. It's very different, which I will explain next Tuesday. For now, let's just study how exactly exception is going to work. Okay. So it will occur when there is some, occur during execution of the program and some error actually occur. So this word is a keyword, guys, here. What do I mean by disrupt? Okay, let me visualize this right away. That's something we have to understand abstractly first before we understand concretely. What do I mean? Disrupt the normal flow. Okay, let's now imagine this. When we talk about exception, it will disrupt the normal flow of execution. So this suggests there are two possibilities over here. When I call a method, if an exception does not occur, I can just proceed normally. That's option number one. What? Possibility number one. Possibility number two, if I call the method with a particular input that triggers an exception, then I will be disrupted in another way. Okay, that's what I meant. And this is a very important high-level idea you want to understand. Let's say we have, caller Callee. Let's say we got C1. And let's say we got M1. Okay, it can be, let me just be a little bit better on the indentation. Okay, void M1 over here. Okay, and let's say we have certain lines of code before we make a method call. Let's say 2 lines. And then we are now declaring, let's say, some objects of type C2. Right? That's something you're familiar with. Object O would be new C2. After that, we say O dot M2. This is a method call. And then after this, we're going to have, let's say, several lines to finish off. 1 line here, and also 1 line over here. Okay? Let me mix it a little bit better. All right, can you see the setup here? So we have caller over here, and we have the callee over here. Right? That's the point we illustrated last time. And now I'm going to explain to you what are the 2 possibilities when exceptions into play. Right? Exceptions. Okay, I'm going to just make a duplicate to make it very clear. Okay, so I don't need this. Okay, good. Let's say possibility number 1, normal. And possibility number 2, abnormal. The same class, really. Okay? And you can, of course, you can imagine that, but I'm not going to do this. You can imagine there might be some parameter that's being passed over here, and that parameter is passed into the method here for input, which we're going to see in a moment. But for now, let's not worry. Okay? So possibility number 1. Let's say when we make this method call, when we do that, let's say no error. That means no exception. And we say no exception thrown from the method call, from the callee. So this is possibility number 1. Okay, we are making this method call here, but nothing goes wrong. So we're supposed to just proceed normally. Possibility number 2. When we try to call this method here, maybe somehow the variable that's involved somehow will cause an error, let's say. It's totally possible. And so let's say possibility number 2 here, some error occur. Some exception thrown from the callee. Can you see I'm trying to lay out 2 possibilities over here? And now I'm going to specify exactly how the program is going to continue. Right? We've got to trace the code in some way. In the normal case, I would definitely have to, let's say I start with this. I definitely have to do this one here, number 1, number 2, number 3, number 4. When I reach this point here, because my assumption is no error occur, that means I can just proceed. All right? I can move on. Let's not worry about tracing M2 itself. We could, but not in this case. After this, we can say number 5, number 6. You can see it's a very normal flow, just from top all the way to the bottom. That's normal. That's something you know pretty well. What about disruption here? We still do number 1. We still start here. Number 2 and number 3. All right? Let's say when we call this method here, somehow M2 is going to throw some exception, which we're going to see how. But for now, let's assume some error occur when we try to execute M2. So some exception is thrown. Now, we are not going to continue anymore. Somehow, this method is going to be terminated prematurely. How about that? That's what I want you to understand. So at this point, these two are not going to be executed. So what you want to know is M1 terminates prematurely because an exception occurred from the callee. Okay? If you kind of follow these two possibilities, I think it's already 50% you understood what we're going to see soon. Okay? I thought mentioning this to right at the front is going to help. Okay. Any question about this? Yes?
So is the exception stem from the method declaration?
So yeah, we're going to talk about it. The question is, how exactly do we throw an exception? That's something we'll see more concretely just in a moment. But I think it is now important, even before we talk about exception, we want to understand, number one, when there is a possibility of exception happening from the callee. So there are two possibilities for the execution flow. Either the exception did not occur in the callee, in which case we just continue. That's okay, that's good, then we're lucky. If the callee somehow throw an exception, in that way, we do not continue anymore from the caller. We do not. Then we simply just break the flow from here. What's going to happen? We're going to see some concrete example later. But you just have to know the rest of the caller code is not going to be executed anymore. Okay? So the plus over here, so the cross here, they will be bypassed. Bypassed because an exception occur from O.M2, right? Okay. Let's now move back. Disrupt, okay? And whenever it's an error, what I mean an exception occur within a method. Somehow the method will throw, okay, so this part here, you can read it, but I'm going to illustrate, visualize it for you. Okay? Whenever an exception is thrown, think about exception is like an object, a particular type, like an exception type, exception class. But you can also create your own exception. I will show you how. It's very straightforward to create an exception in Eclipse. You can generate the code for you to some extent. Okay, let me just, and then, so this part over here is going to be some principle. You're going to follow through the slides, but I'm going to visualize to show to you. Okay? Yeah, a bit dry, so I wouldn't read it off. So you can read it, but I'm going to show you the process over here. Let's now take a look at this diagram here. Okay? So we basically got 4 methods involved over here. Think about this one here. Let me put some name. Oh, I said the main method, right? So let's keep the main method here, the main method. Let's say this is method 1. This is method 2. This is method 3. All right? Let's say somewhere from the main method, we are trying to call M1. Somewhere in M1, we call M2. Somewhere in M2, we call M3. Right? That's pretty much what we discussed before. And my arrow over here on the right-hand side, this suggests the order of method call. All right? So this part over here, the arrow tells you the order of the method call. Which will go this way. So this method is called first, and then followed by this method here, followed by this method, and followed by this method. Okay, that's the sequence of method calls, right? That's something we can also understand. And let's say the following. when we were trying to call this M3 over here, some error occurred. That's why I say here, method where error occurred, and some exception or exception object has been thrown. All right? We'll show how to do that programmatically, but now conceptually, let's understand. So at this point over here, some error already occurred. So no more method call is possible to grow the stack. Whenever an error or exception occur, something got to be done right away to handle the error. All right? So when we say where an error occurs, so this tells you that no more method call. So now at this point, M3, you can think about M3 here. It's a little bit like this situation here. Sorry, let me say it again. M3 here is a bit like this situation over here, where wherever you are executing, some error occur. So now we're going to disrupt the rest and do something about it. Okay? Now, if an exception occurs, there are three things you want to watch out for. Okay, three things. Number one, this is the method where we got the exception thrown, right? So that's why you see throws an exception. This is what we call the origin of the exception. Okay, that's the method where we throw the exception, right? Everything is going to be followed by an example, but I want you to understand abstract idea first. Okay, so this will be the origin of the exception. So what's going to happen is this method here is done. It will be removed from the stack. And then this exception that's being thrown is going to be passed to this method here. And now this guy here is going to have two options to handle the exception. All right? And this is what's called the catch or specify requirements. Okay? So now, so M2 over here, two options to handle the exception. Option number one is called the specify option. Option number two is called the catch option. You can only choose one, but not both. But you must choose one. Okay? Either catch or specify. And you will see on the slides, I believe I kind of mentioned that. You know, this is a slide you can study later. Once we have studied the example on the Eclipse, which I'm going to do in just a moment. This is so-called a catch or specify requirements, right? We're going to see that. I'll get there. Okay. And now M2 somehow choose the specify option. Specify option is a lazy way, just to say, if I'm getting an exception from somebody, I don't want to handle that. I will pass to somebody else. That's why I said forwards or propagates an exception. I simply say, at this point, M2, I'm not going to really catch the exception. What I want to do is I simply get rid of myself and then pass to M1. So exception will still need to be propagated to somewhere. Could be, potentially, all the way to the main method. Could be. Okay. You can think about this is option number one. So forward because M2 specifies the exception. All right, one more thing. So now because the exception now is propagated to here, M1. M1 again has two options there to handle the exception again. Either catch or specify. Two options again. Either to specify, if it is being lazy again, like M2, you simply say, I don't want to handle it. I just pass to the main method directly. It could be, okay? Totally possible. Or it's going to say, okay, let me take the responsibility. Let me handle that right away. And don't propagate it further. Okay? Or catch. And this is indeed the possibility I put on the diagram. So here it will be catch. So in this case, you can see the arrow simply go back to M1 itself. It is not propagated anymore. So we are okay. Okay? That's conceptually why you have to kind of revisit. Okay, so over here, catches an exception so that the exception is not propagated any further. Propagated further. Okay, I'll do a recap, and then we should be ready to do the small example from scratch. Right? For now, I just talk about some idea you should really come back and visit. If you follow not 100%, totally normal. Okay, but it needs to be said, at least for the first time. Let me recap. Whenever you have a chain of method call, and we trace it by a call stack, method number 0, method number 1, method number 2, method number 3, right? That will be the chain of method call, the order. Let's say at some point in the method call, some error occur and some exception is thrown. So this is the point where the stack cannot be grown any further because some error occur. Something got to be done right away. Usually, the exception from the origin of the exception, the exception from its origin will just be thrown to its caller. Oh, by the way, one thing you may want to, you should see that, but I will just mention it to you. If you think about M2 and M3 over here, right? Just to remind you, which I think is worthwhile, you can think about here, M3 is the callee, and M2 is the caller, right? You want to convince yourself when you review the notes. Similarly, when I look at this pair over here, let's say if I look at M2 and M1 over here, okay? And here, M2 is the callee, and M1 is the caller. You can see for the same M2 over here, it could be the caller or it could be the callee at the same time, right? Okay. Now, when the exception actually occurs in M3, it's simply going to throw the exception back to its caller, M2. Now, M2 has two options. Either I simply get lazy, I simply specify the exception, so it will be propagated to my caller. Right? That's option number one. That's why you see the arrow will simply go to here. That's option number one. Okay? If every method in the call chain is lazy, I propagate to him, and main method is also lazy, propagate to the console. So exception will be thrown all the way to the user. This will be a no-no. All right? But it might occur, which I'll illustrate to you. On the other hand, let's say M2 over here is going to do, M2 is going to propagate the exception here, let's say for M1. Now, M1 also has two options. Either it can propagate the exception further, or it can say, I want to take the responsibility to catch it. In this case, M1 is not going to propagate any further to its caller and main method. It's just going to handle that itself. So that's why the error goes back to itself. Okay, that's a recap. Much information here, right? Just make sure you kind of go through them. But let's now really do some concrete example. We'll see how long it's going to take. Yeah? Guys, any question here? Yes? The caller. That's a good question. You might be wondering, for M3, shouldn't it also have two options, either to specify or to catch? Typically, where the exception is first thrown, you don't really try to catch it. Let's say I'm the callee. I'm implementing my method. Somehow the input that's given to me is wrong. I just cannot handle it. What I want to do is I want to throw the exception back to my caller to say, hey, there's something wrong. I don't want to handle just by myself. I could, but that's not typically the way.
And like what you said, like you can't just keep on specifying.
Yeah.
The main, like,
Yep.
Just be like,
It'll be thrown to the console, which we'll see in the example. I'm going to demonstrate. Yes? Yep. Yeah, we'll definitely see one possibility where throw to here, throw to here, throw to here, and then throw to the console. Okay, we'll see that example. All right, if no more question here. Yeah. Okay, with 2 here. You go first. Yeah, go ahead.
So if we catch the exception
Mm-hmm.
M1 and we solve it, then the flow will go back again?
Good question. So basically, if you actually handle the exception over here, the flow is actually going to go with the handler, which will be the try and catch block, which we'll see a little bit later. You were right. In this way, the flow will actually go on, but you got to see the actual Java code to see how it goes on. Yeah. Yes, go ahead.
When it goes to M3 to M2, is it, even though it has no option, is it just called specify?
Yeah, you can say M3 to M2, usually just specify option. You may do catch option sometimes, but I would say typically you would do specify, typically, yeah. But if you really see the need to do catch, why not, right? I'm just saying typically, yeah. All right, guys, how about this? I'm going to do the fresh demo, and why don't we take attendance, get it out of the way. And then, short break. All right, so now I'm going to do a demo on Eclipse to show you how you can build from scratch. Also, you can learn some syntax from how to do exception handling and also throw the exception. There will be some new keywords you have to learn. Let's see. And the source code, which I'm going to demonstrate, is already on the lecture site. You can also download it if you want to. But let me explain what's going to happen here. So we are going to, let me just go to this one here, explain very quickly. We're going to have 3 classes together. And then we're going to see 3 different ways to handle the error. We have class A, we have class B, and we have something called tester. Okay, when we build the call stack, eventually it's going to be something like this. So you can think about, first of all, we start with the tester here. And then inside the main method, this is the first caller. This will be the starting point. So that's why I think about in the call stack, we got tester dot main. That'll be the first one. And then we're going to make a method call over here from B and then MB, method B. Okay, this will be Callee. So that means we got B dot MB, right? The next one. Make sense? And in the context of B and B, we're going to have another method call, which will be from A and then method MA. So that's why we got A dot MA. And inside the class A, MA, there is a possibility that if the input is negative, we might have an error. Otherwise, it will go normal. Right? So you can see a call chain here. It's simple enough, but it can illustrate many good stuff that we talk about abstractly. Right? So we're going to have 3 different versions. So don't worry, I'm going to go version by version together with you. Right? I think we already talked about caller Callee, so this one can go. We don't need it. Now, very important thing, guys. You want to make sure you really understand how I build this call stack over here based on the 3 pieces of code that's given here. Of course, I know the details already, so I can build it quickly. But for you, you may want to convince yourself by building from scratch. Okay? You can definitely spend some time after class. If you got questions, I still got office hour today. Okay. And for this class, it's for exception. Don't worry about it just for now. Okay? We're going to see. So the same code structure here is going to be almost the same for every 3 versions. I'll give you a very quick look ahead. Somehow, this error here is going to be replaced by some exception throwing. All right, so exception is originated from here. And then it's going to be, by default, propagated into this class over here. It's caller. And now this caller here has option. Either to specify it, which will be propagated, or it can catch it, which will be handled exactly here, right? 2 options, like what we talked about. Let's say exception thrown, and it's propagated. Now, for the main method here, also has 2 options, in which case it can be either to propagate it further to the console, or it can be just handled right in the main method, and that's it. So these are the 3 possibilities we're going to see one by one, right? That's just a preview. And that one really nicely corresponds to what I said over here. Right? That's something you really want to revisit to convince yourself. Let's not do it. And I will maybe review this a little bit later. Catch will specify. But we want to see example right away. All right. So there is an exception there. There's an example there that you can download. And then it's called to handle or not to handle, right? You can something you can download and try. That's built from scratch. Let's now have version number 1. Sorry, I really meant to do a package first. Beg your pardon. And I'm going to do package. Okay, let's say version 1. All right, version 1 is going to, let's start with the class A here. Right? We're going to do class A, followed by class B, followed by tester. Right? That's what we're going to do. Let's now do one by one. Maybe the first one is going to take a little bit thoughts, but once you get to the second version, it's basically almost identical, except where we do we do the exception handling. Let's have a new class called A. All right. A bit slow, that's okay. All right, so for A here, let's say we have a, let's say we got a default constructor. We don't need to bother to define it, right? It's going to be there. So we can say void, let's not worry about public. So void MA, and which will take some input I. Okay, and then we're going to say if the input is less than 0, is negative, then we're going to signal some error by throwing in an exception. I'll do that in a moment. Otherwise, things will just be fine. No error. Do the normal stuff. Right? The structure should be very clear. Right? And now, what happens if there's an error? Now, this is syntax you are going to learn. And from lab number 2, you're going to use exception handling, right? So you got enough time to really study for this. Okay, so there's a keyword you got to learn. How do I say I want to generate an exception and pass to my caller? Use the keyword throw, like a verb. And then remember anonymous objects, right? I'm going to throw some anonymous object of type exception. And now we can customize the exception type ourselves. So let's say I want to have an exception type corresponding to negative value error. So I can say throw new negative value exception. I'm just making up the name on the fly. And then usually for the exception, constructor is going to take one argument for string, some message. You can say negative value, and then I can say whatever I it is, I can just use it, right? Just one possibility here. And make sure I put a semicolon. So up to now, I've done the throwing of an exception from A, meaning that method here potentially might throw an exception. And I got some trouble here, right? If you move your mouse over, it is saying that this exception clause over here, let me just move my mouse over, I'll read it to you. The negative value exception cannot be resolved to be a type. We've got to create it. I would say for exception class, you don't need to, don't really try don't try to create it yourself by right-click on the package and create it. There's a way to automatically generate it. If you move your mouse over again, you will see the error there. And then one of the options there, the first one to say create the class negative value exception. That one there is going to create an exception class for you. Okay, so you don't need to memorize the syntax. Click on that. And then nothing you got to change, just by default. Finish. So there is a class here, negative value exception, right? You can see this is something you know. Extends is something to do with exception, which you don't have to worry about. In the written test, I'm not going to ask you any question about the contents for the exception class. For now, you just have to know how to create it yourself for your labs. Okay? And maybe later for your programming test number 2, you will have to know how to write a syntax. That's after lab 2 already, so you don't need to worry too much. And there's something wrong here. Because we were calling the constructor for that exception class with some string arguments. But we got to define that constructor ourselves. Okay? By default, it's not there. So this is something you got to write. You're going to say public and then negative value exception. The same rule, got to be the same name as the class. Okay? And then over here, there's going to be some string message. And here I'm going to use something also you don't need to worry too much. We just have to use it. Super. It also has something to do with inheritance. Don't worry about extends and don't worry about super. Just know that whenever you want to create an exception clause, that's what you have to create. Once we get to after the reading week, when we talk about inheritance, these will make more sense. Okay? That's how we create an exception clause. And we now have a different kind of error, right? And now the whole thing over here, throw new negative value exception, is underlined. If you move your mouse over, it's saying the following: unhandle exception type. That's basically corresponding to what I said earlier about here. I'll show it to you. It's pretty much like the MA is throwing some exception from here, but somehow we need to handle that. The way to handle that typically is to throw it right away to its caller, the specify option. That's typically the case. Okay? We're going to do that to get rid of the error. To handle the exception from where it's originated, specify it. What do I mean by specify it? That means you want to go to the header of the method here and say that this method may throw some exception. That will be it. Okay? That will be a specify option. And there's another keyword you have to learn. This one here, throw, to throw something, right? It's a verb. And now we're describing that MA throws some exception. The different keyword, throws. Did you notice the difference? S here, no S. Okay? And then it's going to potentially can throw this exception. That will be the specify option. For the catch option, we'll see in a moment. So this single clause here tells you whenever a caller calling a method a.ma, they got to watch out for some potential exception being thrown. That's really the message here. Okay? And let's now see how we can play with this a little bit. What I will do is let me create some caller of A. Okay? Let me create under version 1, new, and then let me say class B. Okay, and in class B here, let's have a single method here. Let's call that MB, method B. And then that one there also takes an integer input. And then we're going to make b.mb a caller, right? A, object A would be new A here. And then I'm going to make a method call, o.ma. Method call, right? Now, I have some trouble because if I move my mouse over, OA, that's a different trouble, right? I really meant to write OA, okay? Now, if I have some error underlying MA, okay? Now, let's read it together. It says that the method MA in the type A, in class A, is not applicable to, another error. I really beg your pardon. I really meant to type that, right? That's a stupid mistake. This is really the error you want to see, okay? When you call the method properly, now let's read it. This is to say, unhandle exception type, negative value exception. What is it saying? It is saying that in the context of b.mb, the caller, the callee a.ma over here throws some negative value exception. Potentially, it might do that. If you're trying to call this method here in this context, you have two options: specify or catch, right? You got two options here. The callee throws negative value exception. How do I know? If you go back there, A here, a.ma throws negative value exception, right? Just give me one moment. I'll take your question. Give me one moment. And then there are two ways to handle. So b.mb, the caller, can either specify it or catch it. And for this particular version, we're going to see, let me say B, we're going to see how to catch it. Right? That's a syntax you also got to learn. Question? Throws with S, yes. And specify, what do we say specify? That means you want to specify as part of the header at the API as the method. That's why I call it specify. To say for this method here, I may throw some exception. That exception may either come from myself or from one of my colleagues. All right, so let's now choose option number 2. Catch it. Now, what's the syntax? The syntax is so-called try and catch block. Okay? Try something here, and then catch something here. That's a general syntax over here. Okay, try and catch. That's also something you will practice in lab 2. As far as written test number 1 is concerned, I wouldn't ask you to write it, but you need to know how to read it. Okay? So now let's say we got a try and catch block. The idea would be you want to try some method that potentially may throw some exception. Try it. If the exception really occurs, it will go to the catch block. So what you asked me before, if the exception really got caught, where should it go? You will go to the catch block. Okay? Let's see. So OA.MA, try this one here. Okay? And then I'm just going to put something here to say system.out.println. Okay, try and catch. And then I'm also going to say system.out. I think in the interest of time, I might only do one version today. That'll be the closure of the coverage for your written test 1. I want to do something complete, okay, just for version number 1. I think that'll be okay. So now, let's say OA.MA over here, right? And then let's put some different messages. So for OA.MA, let's say it's, let me say the exception did not occur. All right? This one here, I'm going to say the exception occurred. Okay, there are 2 possibilities over here, right? And I want to create one more class, and then I'll revisit here. So trying, oh, by the way, catch block here, you also got to specify what kind of exception are you catching. So it's got to be negative value exception. And then you got to give it. So this part here will be as if you're declaring some parameter for the method. Okay, so you can still refer to the exception. So now negative value exception. I'll just put a name. Any name will be okay. All right, before I try to say a little bit further, why don't we go to create another class very quickly. And then I think I can use the remaining time to do what I want to do tracing. That'll be enough. And then we can do the other 2 versions when we come back on Tuesday. Okay? Tester. And the tester over here, public static void main string args. Right? And now let's say the tester is going to invoke B. So B, object B. New B. And then you can see B here, .mb. It might take some I here, right? I may or may not trigger an error. So we're going to try 2 different possibilities. Okay? So let's say here, we can say normal case, exceptional case. Let's do normal case first. I can say ob.mb. All right? Over here, I can ob.mb, let's say 23. And then minus 46. Let's do one by one. All right? Somehow, the first method called in line number 8 is going to trigger, it's not going to trigger the exception, normal case. But for line number 11, it is going to trigger the exception. Right? Let's verify that in Eclipse first. I'm going to put a breakpoint right in the beginning, over here, okay? And then I'm going to debug this. Debug as Java application. Take some time, switch. Sorry, just a bit slow. Okay, now we are line number 5, right? Now, let's step over. We are here, right? Let me step into in the next run. Can you predict what's going to happen? If I say step over, is it going to go on to line number 11? Or is it going to do something else? Well, it should really go to 11, right? Because no exception should be expected. So normal, right? (11). Exception did not occur. Somehow it got printed. I'll show you, step into. Okay, so after, okay, let me just do one more line. Let's say everything is done. Okay, one more time, okay? Now let's try this. Launch the debugger. Now we are here, right? If I say step over, now this method call, because it's strictly larger than 0. So I'm not going to expect any exception. So that should be normal case, right? If you recall, what's the normal case? I should be able to proceed to the remaining part. Okay? And now, what's going to happen if I say step over? Or more precisely, am I going to be able to proceed to line number 13? Now really, because I do expect some exception from this Callee over here, ob.mb with minus 46. This will correspond to this case over here, because this method call is going to have some exception thrown. The rest is going to be bypassed. Okay, it's a different flow. All right? Let me go back here. Let's verify that. If I say step over, exception occur. Well, somehow it's actually being handled, so I'm going to step into to show to you. But if it was not handled, it's going to be exception thrown. There's a slight confusion here. But let's now just move on to step into it to see what happened. Okay? Let's now try to step into each one of them to see what's going to happen. Okay? Let's now try this one here. And then let's now step over here. Okay, let's step into it to see what happens. If I step into it over here, now I'm now in MB, right? In the very first line. And it is actually going to go directly to the try block, because I want to call this method here OA.MA. What's the I value? If you move your mouse over, the I value here is 23. That's a normal one. Okay? Now, again, we have choices. After executing OA.MA, do I expect to see? And don't forget, I is right now 23. And I expecting to go to line number 12, or do I expect to go to line number 15? After this call. Is it normal or abnormal? It's normal, right? Because I here is actually 23, right? It's normal. So if I try to step over here, it will just go to 12. All right? Let me do it again. You can try to step into a little bit further. Okay? Okay. Let's now go to this case here, ob.md. Step into. Now we are in the Callee. And then we are now in OA.MA. And currently the I value over here is actually 23. Okay? That's a normal case. Let's do step into once more. If I step into it, I'm now in the in the MA method, right? Now it's going to make a conditional choice. Either the I here, which is 23, it's actually not less than 0. So am I going to expect to see line number 9 or this line here? Should be line number 12, right? Conceptually, right? So if I simply, but there's no line here at the moment. There's no code to be executed, but at least we wouldn't throw the exception because I, right now, is actually 23. So now if I say step over, it's going to go all the way here without throwing the exception. That's important. All right? One more round. This will be some exercise you will want to do to convince yourself to see the different flow. Okay? Let's now do one more. And then we still got 5 minutes, but I should be able to do one more round, and then that'll be it. Okay, let's now move on to here, the second one. Okay, this is important. Minus 46 at some point is going to trigger some exception at some point. Okay, let's now step into it to see how that's going to happen. Step into. Now we are now in MB, it's Callee. And then if I step over, I'm going to go into the try block here. Now, we're going to decide, am I going to expect to see line number 12 if I step over, or am I going to expect line number 15? 15, because here, OA.MA over here with the I is currently minus 46. Some exception should be thrown from over here, meaning that I should be disrupted to number 15. If I step over, indeed. So for written test number 1, since I only cover up to here, I'm going to focus more on normal versus abnormal execution flow. Okay? But next Tuesday, even though it's not really covered, but when we talk about some more advanced usages, you might get some more insight. But those advanced examples will not be covered, right? But for the simple one, you should at least understand. One more, and then we're done. I want to step into exactly how the exception occur. That will be the last one. Okay, now debugger for the final time. And then step over. Okay, now step into. And then I'm going to step over. Okay, now OA.MA, I want to step into it as well. And don't forget the I value right now is minus 46, right? If I step into it, I'm now in this very origin of the exception. And you can see here, I is 46, minus 46. You can even check that. You can try to see minus 46 less than 0 is false. Sorry, it's actually true. That means I'm going to execute this block here. I'm going to throw the exception. This is where the exception got thrown. As soon as I say step over, it's going to throw the exception. And you'll be propagated because I specify it. You'll be propagated back to its caller, which will be B.MB. And then if I do that, it's going to throw it. Let's throw it. That's why we get to the catch block and then line number 15. Right? And if I step over again, that's exactly what we just saw in the last round. Yeah, let me make a very quick recap, and I'll take a question. How about that? All right, so I think that the code demo here, the version number 1 has been demonstrated thoroughly. I think that's all you need to know about exception handling, and also plus what I said today for written test 1. Let me recap very quickly, and then I'll take a question. So you want to be very clear about the exceptions may generate either normal versus abnormal flow, depending on whether it occur or not. And in that version 1 that we spoke about, we basically say this is the origin of the exception, right? It may or may not throw the exception depending on the input value. You want to be clear about whenever you're making this method call here, if it occurs, you're going to be disrupted for the flow. If it doesn't occur, you're going to go proceed with the remaining lines of the method. All right, any question? As we still got 1 minute. Question, go ahead. If you choose, okay, the question was, let's say here, class A here, let's say we don't really have the, if we don't really have the specify option, let's say you try and catch it. What's going to happen is, if you try and catch it here right away, you don't need to specify, of course, only one option there, just choose the catch option. And then the caller over here no longer need to try and catch. They don't need to be subject to the requirement anymore. This one is a little bit more advanced, which I will save that for Tuesday. Okay? But as far as your written test number one is concerned, let's be fair. Make sure you understand all the points I illustrated today. Make sure you understand how to trace code like that, and you should be fine. I'll try to maybe, I'll try to see if I can do it. I'll try to maybe extend your example question maybe with 1 or 2. So just to test your knowledge about this. But you got to study this first. It's tricky, and it does require some time to think through. All right, thank you. And I'll reach out to you about other things.